Okay, let's go. Hello, everyone. Thank you so much for joining. Let's see how many people are here. 133. I'm so glad that you all are here. So, yeah, we are doing some finance today. And I really hope that after today's session, you will be able to get full marks for the section. It's really supposed to be a small section, but like I said already, if you can get these marks, that's amazing. Then you are already 15 marks in. All right, so this is last year. I'm going to go backwards. So I'm going to start with November 2022, and then I'll work my way back from here. I do suggest that if you are looking at past papers, that you look at the more recent ones first, instead of going from the oldest ones and working your way up. They tend to kind of have the same layout every year. So you'll see in all the finance questions, it's normally 2 or 3 questions, and they kind of, yeah, it's always kind of the same layout. The first question is just a straightforward question: compound interest, compound growth, or compound depreciation, which we call reducing balance. That's normally the first question. Then after that, they'll ask something different, and then maybe like an annuity or so on. And then after that, they usually have a question that has a bit of a trick in it. All right, so question 6 from last year's exam, 6.1. Let me just write here, 6.1. Okay, 12,000 Rand was invested. Let me just see if everyone can see what I've written now. Yes. Okay, 12,000. Yeah, this is for grade 12. All right, 12,000 Rand was invested in a fund that paid interest at M% per annum. So already there we can see that is what we're going to have to calculate. And very important, it's compounded quarterly. Now, quarterly means 4 times a year. That is important. If it's M% per annum compounded quarterly, we are going to have to write M over, now you can decide if you want to write M over 4 or M over 400. It's up to you. You will get the marks either way. Right? After 24 months, now that's another spanner that they're throwing at us, because 24 months, but it's compounded quarterly. Now, very important, guys, if you are working with a quarterly interest rate, then your number, your time period also needs to be in quarters. So we can't put 24 as our exponent in our formula that we're going to use. We have to figure out how many quarters there are in 24 months. Now, we'll do that just now. But they're saying after this time period, the value of the investment was 13,459. Determine the value of M. All right, now this is just one payment that's been made, one investment. So it's not an annuity. So we are just going to use our normal compound growth formula. All right, so A is the final amount, the accumulated amount. That is going to be 13,459. P is the principal amount, the original amount. So P here in this case is 12,000. That is the amount that was invested at the beginning of the time period. 1 plus, now this is where we're going to either have to write down M over 4 or M over 400. So Jamie Lee was asking here how I got to 400 here. Yes, I did multiply by 100. So if you are told that it's maybe 12%, right? You can decide whether you want to write this as 0.12 or 12 over 100. All right, I think we're all fine with that. But if they then say 12% quarterly, that means that you are still getting 12% over the whole year, but they are now splitting that 12% into 4 quarters. So you are either going to write that as 0.12 over 4, or you can write 12 over 100 divided by 4, which is the same as 12 over 100 times 1 over 4. Oh, sorry, that's off the screen. My apologies. Which is the same as 12 over 400. All right, that's a very long-winded way of writing it. You don't have to write it in that way at all. You are more than welcome to write it as 0.12 or whatever the interest rate is over 4 for quarterly. But I know that some people prefer to work with it in this way. So 12 over 400. I normally write it as 0.12 over 4. Or whatever the interest rate is that they've given you, but you will get the marks either way, whatever works for you. I will post this recording on YouTube. Yes, absolutely. All right, so let's go back to this. I personally am going to write M over 4 for this one. But if you want to write m over 400, fine, you will get the same answer. Now, guys, we come to this 24 months thing. Since our interest rate is quarterly, I'm just going to say this again, our number of payments has to be number of quarters, essentially. Remember, n is now actually, sorry, not number of payments. N, yes, I will post this on YouTube, absolutely. N is the number of time periods, number of quarters in this case, because the interest rate is quarterly. So 24 months, guys. I think we all know that 24 months is equal to 2 years. Right? And how many quarters are there in 2 years? 8 quarters. There are 4 quarters in 1 year. Right? 1 year is equal to 4 quarters. 2 years will be 8 quarters. Oh, I see here. You should have seen our IB Maths paper 1. I've actually, I have the paper, but I haven't looked at it yet. I'm going to work through some questions once I have some time. All right, so Danielle is asking, how did I know to use this formula and not the future value formula? So the future value formula only works, or you only use the future value formula for an annuity. Now, an annuity is where you are making equal payments at a regular interval. So if you are making a payment every month or every quarter or every half a year, right? So here, because there was just one amount of 12,000 Rand, that's not a regular payment. That's not a payment that's made every month or every quarter. We are just going to use the basic formula. All right. Would there ever be an instance where the interest is already divided per quarter for us? Not that I've seen. They usually just give you the full percentage and then they tell you that it's quarterly, so you must do the dividing yourself. I haven't seen a question where they've divided it already. All right, now here, this is going to be to the power of 8, right? Because in 24 months, there are 8 quarters. I'm going to be live until 5 o'clock. All right, now guys, all that's left for us here to do is to solve for m. Okay, so the first thing that we're going to do is we're going to take 13,459 and we are going to divide it by 12,000. Now I am getting 1,1215 ... You can write this in decimal form, or you can write it as a fraction if you want to. If you want to say 13,459 over 12,000, that's also fine. And then I'm left with this whole bracket, 1 plus m over 4 to the power of 8. Now, the opposite of raising something to the power of 8 is taking the 8th root. So you're going to do 8th root of 1,121, ... Now, guys, when you type this into your calculator, it is very important that you not round off. So in your calculator, yes, absolutely, Bianca, you must not round off. You must keep this in your calculator, and you're going to do shift and then the button with the little surd with the block. You're going to put an 8 there, and then you're going to use the answer button and press equals. And that is the amount that we're going to work with. You only round off your final answer, you're not going to round off in your in-between values. I see that some people are asking questions. I'll read through them at the end, okay? I just don't want to interrupt this process every time. So, okay, that is what I got when I put that into the calculator. The next thing that we're going to do is we are going to minus 1. Again, on your calculator, you just press minus 1 and it uses the unrounded value, 0,014. And you don't have to write this ... every time. I'm just writing it there, I suppose, out of habit, but also just to show the marker that I haven't rounded off. But you won't lose marks if you leave the ... off, okay? So that is now m over 4. Next step, we need to times by 4. So now I'm getting that m is 0,05778, and then there are some more numbers, right? That. But guys, that is not in percentage yet. I still have to multiply this by 100. So that's what you do on your calculator. You times by 100, and only now in your final answer are you going to round to 2 decimals. So you see, when you times by 100, you get this 5,778, which you now are allowed to round up to 2 decimals. Okay, let me quickly look at these questions. What do we do when we are given the number of payments as months and not years? Well, then you would just have to convert. yeah, you have to always match the type of time period with the type of interest. So if it was compounded quarterly, you need to have quarters. If it was compounded monthly, you need to have months. Yeah, it just depends on the question. How did I get 8 quarters? Because it's 24 months, which is 2 years. And remember, 1 year is 4 quarters. So I just multiplied 2 by 4 to get 8. Why did n change to 4? Why did n change to 4? Maybe you mean this, m over 4. It was, what's it called? Quarterly interest. The m is the percentage per annum calculation that you did. That is how much per annum. Yes. So this is, you don't have to write that, but this would be 5.78% per annum compounded quarterly. That would be the full answer, but you don't have to write that. You can just leave it as 5.78%. Can I divide by the quarter at the end after getting the percentage? You could, yes, that would be fine. Timna, yes, you have to convert to percentage, absolutely, because they are asking for m percent to determine the value of m. Right, so your answer has to be m and percentage. So Demira, I'm going to do these lessons every day of this week except for Thursday from 4 to 5, and then Friday I'm going to do 3:30 to 5. Yes, to get this from here, I multiplied by 4, and then that was my answer, yes. All right, let's look at the next question, 6.2. If you guys have more questions, you can just put them in the comments, and I will look at them after this. In which cases do we not multiply the n with how much it has been compounded? Hope I make sense. So only if it was compounded annually. So if it wasn't like quarterly or monthly, then you wouldn't have to do that extra multiplication. But if it was monthly, you would have to times by 12. If it was quarterly, you would have to times by 4. Right, it just depends on the question. Okay, let's take a look. 6.2. On 31 January 2022, Tino deposited, let me just erase this here, it's a bit busy here on the side. Tino deposited 1,000 Rand, I'm going to highlight that, in an account that paid interest at 7.5% per annum compounded monthly. So I'm going to put that 7.5% over 12, right? Because it's monthly now. He continued depositing 1,000 Rand on the last day of every month. So now the fact that he is continuing to deposit the same amount at the end of each month, that makes this an annuity. So now because of that, we are going to use the future value formula because it's an investment. So we're going to use the future value. He will make the last deposit on 31 December 2022. Now guys, when we're working with an annuity, the n value is the number of payments, the number of deposits that are made. So if he's making his first deposit on the 31st of January 2022 and he's making a deposit every month of that year until the 31st of December, he is effectively making 12 deposits, 12 payments. So that is going to be the n value in this question. Then they're saying, or they're asking, will Tino have sufficient funds in the account on 1 January 2023? So that is just after making that last deposit, to buy a computer that costs 13,000 Rand. Justify your answer by means of an appropriate calculation. Okay, so now we have to calculate basically how much money will be in that account. If it's less than 13,000 Rand, he's not going to have enough. If it's more than 13,000 Rand, he will have enough. So someone is asking, Fatima, how do you know when to use future value and not present value? So I always say if it's an investment, so you're saving up for something in the future, then you're going to use future value. But if it's a loan, you get an amount at present that you must then pay off. So that is then present value. So investment is future value and loan is present value. That's how I always remember the difference between the two. Okay, so let's start filling everything in here. I'm quickly going to write the future value formula down. This is, of course, on the formula sheet, but you have to know which one to use. All right, so 1 plus I to the power of n minus 1 over I. That is the future value formula. So are you talking, okay, so someone here is saying getting 0,056. You probably rounded off in between. All right, so just make sure that you are not rounding off at all. You're keeping the full answer in your calculator always, and then only at the end must you round. How do I know when you add a day or take one away? The end of a month is technically the same as the beginning of the next month. So in this case, where they're talking about 31 December and then 1 January, we're not going to work in days. All right, this interest rate that we have was compounded monthly. So that means that only at the end of the next month will they calculate the new interest. So 1 day here is not going to make a difference. Okay. Draco edits. I'm only going to do finance today. There is a schedule on my TikTok. I posted a video earlier today, and then also on my Instagram of what's going to happen for the rest of this week. All right, let's now start by filling in everything. Remember, we just want to get the future value. So this is actually a very easy question. We must just fill in everything. X is the monthly payment, right? And he is depositing 1,000 Rand at the end of each month. The explanation of what, Abigail? I'm just going to fill in here. What was this interest rate again that they told us? It was 7.5% compounded monthly. So I'm going to write that as 0,075 over 12. And now remember, he made his first payment at the end of January, and then every month after that until the 31st of December. So that was 12 payments. And guys, if you are not sure, you can literally count it off on your fingers. No one's going to laugh at you. You just count. You just see, okay, 31 January, then that's 1. Then end of Feb, end of March, end of April, end of May. You count it like that, and then you're absolutely sure that you've used the correct number of payments there. And then 0,075 over 12. Okay, while I type this into the calculator, I will explain again how you know when to add a day or when to take a day away. So in the context of finance, the end of 1 month is technically the same as the beginning of the next month. So end of December is the same as beginning of January. So you don't have to worry about that. This interest rate is compounded monthly, and what that means is that the interest is only calculated at the end of the next month, right? So 1 day is not going to make a difference. Okay, so we view 1 January 2023 basically as the same as 31 December. All right, so that is the value that I'm getting. I can just show you on my calculator. That's what I got. Now, remember, what was the question? Will Tino have sufficient funds in the account on 1 January to buy a computer that costs 13,000 Rand? Unfortunately not. So now we're going to say this is less than 13,000. That's just my little reason for my answer there. Therefore, no. Or if you have time, you can write, he will not have enough money for the computer. Or he will not have enough, or just something along those lines. But no is also fine. They'll know what you are saying. All right, let's look at 6.3. Thabo plans to buy a car that costs 250,000 Rand. He will pay a deposit of 15%, so that is important. I'm going to highlight that. Deposit, okay, let's highlight the 250,000. Deposit of 15%, and take out a loan for the balance. So guys, if the deposit is 15%, the other 85% is going to be the loan, right? The interest on the loan is 13% per annum compounded monthly. Again, we have compounded monthly, so we're going to take number of years multiplied by 12, if they tell us the number of years. So 6.3.1, very easy. They are asking us to calculate the value of the loan. Now, like I said already, the deposit is 15%. That means that the loan is going to be 85%, right? 100% minus 15% is 85%. So that is a quick way of calculating it. So for 6.3.1, I'm going to write here, loan equals You can write 85%, you can write 85 over 100, or you can write 0.85 times, what was this now again? I forgot, 250,000. You don't even really have to write this working step down. You can actually just calculate it. It's a 1 mark question, so that means you are just getting a mark for the answer, which is 212,500 Rand. Right? If they had asked for the deposit, you would do the other calculation. So you would say that the deposit is 15%, which is what they told us, obviously, of the 250,000. So that answer is going to be, I don't want to make a mistake here, 37,500. So you are more than welcome to do this calculation and then say loan is 250,000 minus 37,500, and then you will also get your answer. You'll get this answer either way. Right, 1 mark question. So all you're going to get is 1 mark for the answer here. Thank you so much for sharing the live, guys. So many of you have done that. That's really cool. Okay, 6.3.2. Now the next question, this is now, remember at the beginning I said the finance questions, there's usually one question that has a bit of a twist to it, and this is now the one with a twist. All right, so now they are saying the first repayment will be made 6 months after the loan has been granted. So this person, so Thabo is getting the loan and he's not making the payment at the end of the first month as you normally do. Normally you take out a loan, you get your money, and at the end of that first month you make your first payment. He is making his first payment 6 months after the loan has been granted. The loan will be repaid over a period of 6 years after it has been granted. Calculate the monthly installment. Now, if we're looking at the future value or the present value formula, both of them, X is the value of that installment that you're going to pay. So we are going to actually have to calculate X. Now, again, guys, we need to decide, are we using the future value formula or are we using the present value formulas? As this is a loan, we are going to use the present value formula, right? So because it's a loan, we are going to use P. Now, before we get into the values that we're going to sub into this formula, and before I actually write the formula down, we need to talk about the 6 months after the loan has been granted business. This is called a deferred payment. I'm just going to write a little note here. I almost said loan. I'm just going to write a little note here. Sorry, I'm stumbling over my words. It's been a long Monday. I'm sure you guys are tired after writing your exam today. All right, so deferred payment. What that means is, yes, we are using present value. Well done. A deferred payment is exactly what's happening in this situation. You don't pay at the beginning, at the end of the first month, as you usually do. You pay a certain amount of months later. So usually, I'm going to write here, usual first payment equals end of month 1, end of the first month, right? That is what the present value formula is set up for. Okay, so that is what how we usually use it. We use the present value formula. If they say first payment is made at the end of the first month, that is the normal scenario. Now here, this first payment, maybe I should have written Thabo's first payment, but you guys know what I mean, is made at the end of month 6, right? They're telling us 6 months after this loan was granted. So that is at the end of month 6. Guys, how many months difference is there between end of month 1 and end of month 6? There's actually a 5-month difference. And that is the trick to this question. That is what most people got wrong last year when they attempted this question. Most people added 6 months instead of 5 months. Guys, I hope that makes sense, right? You normally pay at the end of the first month, but now you are paying at the end of the 6th month. That is actually only 5 months later. A 5-month difference between those. Now, what that means, guys, in the 5 months that you are not paying, or that Thabo is not paying, right? Because he got the money, and then 5 months pass, and he hasn't paid a cent. At the end of that 5-month extra period, he doesn't still only owe 212,500 Rand. No, the bank is going to charge him interest for those 5 months. So the first thing that's going to happen is that the P value, the present value of the loan, is going to be more than it was. So the P value increases with 5 months interest. So we're going to have to calculate that. That is the first thing that we need to take into account when we are working with a deferred payment or deferred payment question, is that the P value is not going to stay the same. We are going to have to add 5 months worth of interest. And guys, the way that we're going to do that is by using the A equals P bracket 1 plus I to the power of n formula. So this is the formula that we are going to use. We're going to take our P value, our original P value, right? The 212,500 Rand, the loan amount, and we're going to add 5 months worth of interest. So that n value there is going to be 5. Okay, that's the first thing. The second thing is, because for the first 5 months, Thabo is not making any payments, over the 6-year period, he's actually going to make 5 payments less. So the number of payments is also going to decrease by 5. Number of payments decreases, because the number decreases by 5. So we need to calculate how many payments would he have made in the 6 years. He would have made 6 times 12 payments, right? 72 payments. That is how many payments he would have made if he started paying when he was supposed to start paying. But now, because there are 5 months where he doesn't make any payments, he is actually not going to make 72 payments. He is going to make 67 payments in total. So guys, this is very important. In the type of question where you start paying later, there are 2 things you need to take into account. Firstly, you need to increase the loan amount with the extra interest. And secondly, you need to decrease the number of payments with the number of payments that the person has missed. All right, so those are the 2 things. I'm actually running out of space a little bit here, but hopefully I can... I don't think I'm going to fit it in underneath here. Let me quickly move this up. Move 6.2 up into that little gap there, and then I can move this up. Sorry guys, I'll zoom in again now so that you can see. All right, I hope that that makes sense. The 2 things that I have written down now that we need to do. Now, if you look at the actual memo from the end of the year, they do this in 2 separate calculations. I'm going to show you how to do this in one calculation. I think we all recognize that we need to use the present value formula, right? It's a loan, so we use present value. So I'm quickly going to write that down. Present value is equal to X. Remember that the present value formula is the one that has a negative n, negative exponent. That's very important that we remember that negative n, and it is then again over I. Now here for this P value, I'm now going to, in this calculation, or in this, on the side of the equation, I'm going to do that calculation. I'm going to calculate the new present value by doing 212,500, the loan amount that he would have had to pay if he paid immediately, bracket 1 plus, what was the interest rate that we're working with here? 13% per annum compounded monthly. So I'm going to say 0,13 over 12. So it's 13%, but because it's compounded monthly, we divide that by 12. And now, guys, how many months interest do I have to add? 5. So this is going to be to the power of 5 there. Don't get confused and put a 67 here. This is where I'm adding the interest, right? This must now be equal to, remember, I'm calculating X. That's what the question was asking for. 1 minus bracket 1 plus. Again, the same interest rate. 0.13 over 12. Now here is where we're going to put the negative 67 in. So it would have been 72 if he started paying immediately, but he missed 5 payments, so it's actually 67, and then that is over 12. Now guys, we need to solve for x, so we need to get everything else away from the x. The first thing that we're going to do is we are going to take this whole value and we're going to multiply it by 0.13 over 12. So we're going to say 212,500, this is on the calculator, right? Bracket 1 plus 0.13 over 12. We're going to close our bracket to the power of 5, and that we are then going to multiply by, again, 0.13 over 12, and we are going to get sorry, I didn't want to do that in blue, 2429,510, blah, blah, blah. You can just keep that in your calculator. You don't actually have to write that down. Equal to x with this whole bracket. Now, guys, it's actually fine if you don't write the step down, okay, because it is quite a lot of writing to do. You can, you don't have to write this down. You won't lose a mark if you don't. You can just in your head think, okay, first I must multiply by this, and then I must divide by this whole bracket. Because, guys, remember, we're getting x, right? And x is being multiplied by the whole square bracket here. So to get rid of that square bracket, I must just divide by it. So I'm going to take this answer as it is. I'm going to say divided by, and now I'm going to type this whole square bracket exactly as it's written there with the brackets in their places. I'm going to just type that in to the power of negative 67. I'm going to close my bracket again, and then I'm going to get an answer for x. And that value is 4,724 Rand and 96 cents. Right, that's it, guys. That was let me quickly see, I think 5-mark question. Let me see here if I can quickly find this memo to see what you got marks for. All right, so it was 1 mark for doing this calculation. Then there was actually another mark for getting this answer, but if you've written it in one long line, then you will just get 2 marks for that, which is lovely. Then a mark for substituting into the correct formula. So if the marker can see that you've used the present value formula, right? And then there was a separate mark for negative 67. And then the final mark was for the final answer. So this line actually is worth 4 marks. And you see, you don't get a mark for this in-between step, so you can go straight to the final answer. Yes, you don't have to simplify exactly like I did. That's absolutely fine. Whatever works for you, however you can solve for x is fine, as long as you get to the same answer. All right, well done, guys. That was a tricky question. I hope that you have managed to make a note of this deferred payment business and what you need to take into account there. What you did to get answer from this line. So I took this whole expression and I multiplied by 0.13 over 12, and then that's what I was left with. Then to get x on its own, I need to get rid of this bracket, so I just divide it by the whole thing. Yes, let me zoom out so you can screenshot the whole page. There we go. I am recording this. Yes, I will post it on my YouTube later. Alright guys, I hope that was useful. I want us to look at the November 2021 paper now as well. If I can just quickly check here. In the November 2021 paper, I really want to get to the last question because the last question had something that is quite tricky, but I want you guys to write the kind of formula down for it, and that is how to calculate the interest amount paid. So, if we are going to question 8, this is now from the November 2021 exam. Again, the finance question. Sorry, let me just straighten this up a bit. It's looking a bit skew. All right. So 8.1, I'm going to go through it very quickly. 8.1 was a very simple question. You see what let me just check. It's a bit blurry. I hope you guys can read what's written there. Let me maybe move it down a bit. All right, remember what I said in the beginning. The finance section usually starts off with a question where you just have to use either compound growth or compound depreciation, one of those 2 formulas, and that's how it's been for years. So that is what I expect to happen in Friday's paper as well. So that's what also happened here. 8.1, they're saying a farmer bought a tractor for 980,000 Rand. The value of the tractor depreciates annually at a rate of 9.2% per annum on the reducing balance method. Now, reducing balance, that is compound. Right, you have to know that. Straight line depreciation is simple depreciation, and reducing balance is compound. You have to know that, please. Calculate the book value of the tractor after 7 years. The book value is just the A value, right? What that tractor is worth after 7 years. So very quickly, 8.1, I'm going to write down that formula. The compound depreciation formula is very similar to the compound growth formula. It just has a minus in the bracket instead of a plus. But apart from that, everything else is the same. So we are going to put the original value of this tractor in first, 980,000, bracket 1 minus the rate of depreciation was 9.2%, and it's per annum, right? It's not compounded monthly or anything like that. That's the nice thing about the depreciation, is it's always just very straightforward. So I'm going to write that as 0,092. But if you want to, you can write it as 9,2 over 100. That's also fine. You'll get the same answer. To the power of, how many years was this? 7. Sorry, I know I'm going fast, but it's because I want to get to the end questions here. So 980,000. I'm just typing that into my calculator to the power of 7. And I am getting an answer of 498,685 Rand and 82 cents. There we go. Hello, Jared. All right. 8.1, done. The first question is always a nice, easy question. All right. 8.2, let's look at this one. This I also want to go through because 8.2 is actually a logs question, which is important. How many years will it take for an amount of 75,000 Rand to accrue? Now, when they say to accrue, that means to grow, right? To increase to 116, blah, 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 in an account earning interest of 6.8% per annum, compounded quarterly. Now, guys, we must be careful here because if it's compounded quarterly, right, that means that we're going to put this interest rate over 4. And then when we solve for n, the answer that we're going to get is going to be the number of quarters. Then we must remember they're asking for how many years. So we're going to have to take the number of quarters and we're going to divide it by 4. All right. Jared, where did you message me? On which platform? All right, let me quickly write this down. So 8.2. How many years? Okay, it's compound interest. So we're going to write down the compound interest formula on TikTok. Oh, sorry. Okay, I'll check now. A equals P, bracket 1 plus I to the power of N. The accumulated amount is 116,253.50. This is the November 2021 paper. 253.50 equal to the original amount, the principal amount. The amount that was invested originally is 75,000, bracket 1 plus. The interest rate, like I already said, is compounded quarterly. So it's 6,8, so that's 0,068 over 4, right? Because it's compounded quarterly to the power of n. Now, some people in this step already will write 4n because they'll recognize, okay, it is... No, this is not simple interest. This is compound interest because the n is on the outside. Remember, for simple interest, the n is on the inside of the bracket, okay? Some people will put a 4 in here as a reminder that because we're working with a quarterly interest rate, this is going to be number of quarters. But I usually just remember to divide by 4 at the end. But if you think that it's safer to put a 4 in, because then you have to automatically divide by 4 to get n on its own, then you can also do that. Okay, it's up to you. You'll get the same marks either way. Now I need to solve for n here. The first thing that I need to do, guys, is I need to move this 75,000. So in my calculator, I'm going to type 116,253,50, and I'm going to divide it by 75,000. Why are we using the compound formula? Because for present value, you only use that if it's an annuity, so you're making regular payments, the same number or the same amount you're paying every month or so. This is just one amount of 75,000. So if it's just one amount, then we only use the compound interest formula. All right, so I'm getting this when I do that division, right? 1,55. So I am going to write 1,55 dot dot dot. I have said this before, you don't have to write the dot dot dot, but you can if you want to, as a reminder that we're only allowed to round off in the final answer. Not yet. Not at this point. So you can't work with 1.55 going forward. You have to use this full answer in the calculator. All right, I'm left with this fraction, or the bracket rather. 1 plus 0,068 over 4 to the power of n. Now this is where we get to the point where we have to solve for n, which is in the exponent. This is an exponential equation. So now, oh great, thank you Hope for that, for that vote of confidence, lovely. So this is an exponential equation, and usually when we have to solve an exponential equation, if we have something like this, right, we would say that we need to make the bases the same. And then we would say if the bases are equal, we're going to make the exponents equal. All right, in this case, we can't do that. It's going to be too complicated to write both of these sides of the equation, hey, until 5e. Sorry, it's going to be easier, or it's going to be difficult for us to make both sides of the equation to give them the same base, right? Because these are decimal values that I'm working with. So now we're going to use logs. So we're going to change this into a log equation. So we're going to say n is equal to, guys, the purpose of logs is to solve for the exponent. So the exponent becomes the subject. Just quickly going to turn off invites for the live there. People are trying to join. All right, so we are going to make the exponent the subject of the equation. Then you're going to write log. You don't have to use a cursive L like I do. I'm always worried that I'm going to confuse the L and a 1. Now, guys, the base of the log becomes the base of the exponent becomes the base of the log. Yes, we are using logarithmic formula. So I'm going to say again, the exponent becomes the subject, the base of the exponent, so this whole bracket becomes the base of the log. 1 plus 0,068 over 4. And then the number that's left over, which was the answer that we got in the previous calculation, I still have it here on my calculator. That is the last number that's left, so that is what comes after the log. Exponent becomes subject, base of the exponent becomes base of the log, and then we put the next number. So I'm going to show you now how I'm going to type this into the calculator. You are still going to keep that value there. You're going to press this button, the log button, with the 2 little blocks. In the first block, you're going to type this whole bracket. So you're going to say 1 plus 0,068 over 4. You're going to close your bracket. On the outside or next to that, you're now going to use the answer button, right? So that it uses the previous full answer from the calculator. You're going to press equals. There's your answer. 25,9999666 quarters. Right, 25,999 dot dot dot. This is the number of quarters, guys, because we are working with quarterly interest. The question was asking for the number of years. Now you need to ask yourself, how many quarters are there in a year? 4. So now you are going to just on the calculator type divided by 4, press equals, and that is your answer, 6.5 years. So therefore that is 6.5 years. How do you get the n on the other side? That is what happens when you are converting an exponential equation to a log equation. The exponent becomes the subject. All right, so that n goes to the other side because I'm writing this in a different form. All right, so that is how you use logs to solve for n. Whenever you have to solve for n in a compound interest formula or a future or present value annuity formula, you are always going to have to use log. So it's very important that you are able to do this conversion. All right, you have to be able to do it for when you're working with log functions as well. So yeah, make sure that you are able to do that. I'm just going to say again, exponent becomes the subject. When I say the subject, that's the thing that's on its own, right? On the one side of the equation, base of the exponent becomes the base of the log. And then you put the other number after that. Okay, now we are quickly going to do 8.3. We have 10 minutes and I really want to get to this one. So for 8.3.1, very quickly, they're saying here, Tabo wanted to save 450,000 as a deposit to buy a house on 30 June 2018. All right, 30 June 2018, I'm going to just highlight the 450,000, that is going to be the deposit, right? And he wants to buy this house, or he wants to pay this deposit on the 30th of June 2018. He deposited a fixed amount of money at the end of every month. So guys, end of every month, that means that this is going to be an annuity. We need to think, is it an investment? Then we're going to use future value. Is it a loan? Then we're going to use present value. Because he's depositing a fixed amount of money and he wants to save 450,000, we are going to use the future value formula for this. He's saving up for an amount in the future. He wants to have 450,000 Rand at some point in the future. Then they are saying that this account earns interest of 8.35% compounded monthly. His first deposit was made on 31 July 2013, and his 60th deposit, guys, that's very nice of them. They're telling us how many payments he has. We don't have to worry about that. We don't have to calculate how many payments there are going to be. N is going to be 60. That's really nice. Calculate the amount he deposited monthly. So for this first question, they want us to calculate X. All right, so let's quickly do that. I'm going to say again, we are using the future value formula. This is what we are looking for. This is the future value that we're going to put in, and we are going to calculate X. That is what they're asking for. All right, so I'm quickly going to set that up. 8.3.1, I'm going to write the future value formula, which again is on the formula sheet that you get. You don't have to memorize it, but you have to obviously know which one is which, or you have to know when to use the future value formula. All right, that is then over I. The future value is what he wants to save up. He wants to save 450,000 Rand, equal to X is what they've asked us to calculate. 1 plus the interest rate that they told us is 8.35%. So I'm going to write that as 0.0835. And it was compounded monthly, so we have to divide that by 12. They told us that there are 60 payments. So it's to the power of 60, and then we are putting 0.0835 over 12 at the bottom of this fraction. All right, now I'm going to do my calculations all in one step. I'm not going to write the middle step down. I am first going to take 450,000 and I am going to multiply it by this bottom fraction. All right, so I'm doing that on my calculator. I'm just typing it in quickly. There we go. Equals, I'm getting this value, or if you want to, you can write it like that. That's actually quite a nice value. Carrie Ann, yes, you can write it as 8.35, but then you must put it over 1200. So you can write it like this, 8.35 over 1200 essentially. Because it's actually 8.35 over 100 that you are then dividing by 12. All right, so that 12 then goes next to the 100. Absolutely, you can, oh, sorry, that's on the screen now. You can definitely write it like that, okay? But not just 8.35 over 100 over 1200. All right, now guys, this number is what is equal to this whole thing here, right? To get X on its own, I need to divide by this whole fraction. So on my calculator, I'm going to press the answer button. I'm going to say divided by, and now I'm going to type this whole square bracket as it stands, with the double brackets and everything. Guys, you have to type it in exactly as you've written it down. Otherwise, you actually might not get the correct answer. Okay, be very careful of that. And that is what I am getting. 6,068 Rand and 69 cents. All right, so that is my X amount. If you're a bit nervous about doing this all in one step, you can write down the middle step like I did for the previous question in the previous paper that we looked at. All right, you absolutely can do that. Okay, so that is now the amount that he is paying monthly. Now, 8.3.2, this is what I want to get to. Thabo bought a house costing 1.5 million Rand and used his savings as the deposit. So remember, he saved up 450,000, right? So the actual loan, they're saying here, he obtained a home loan for the balance of the purchase price at an interest of 12% per annum compounded monthly over 25 years. So here, our loan amount, the actual present value of the loan that he is going to receive is going to be 1,500,000 minus the deposit, right? Which is what he saved up. So this is going to be our P value, the loan. That's going to be our present value, is this amount. Okay, that is very important. He made his first monthly installment of 11,058 Rand and 85 cents towards the loan on 31 July 2018. Okay, so they're even telling us what the X amount is as well. I'm just going to highlight everything that we need to use here. This is what we're going to use for our P value. The interest rate is 12% per annum compounded monthly. It was for 25 years. So that's going to be 25 times 12 as our number of payments. And they are telling us what the first or what the monthly installment is. Guys, these two questions are different scenarios, right? This was an investment in order to save up for the 450,000 Rand. 8.3.2 is now a completely different annuity. This is now a loan that he is taking out to pay for the rest of the house, right? He saved up 450,000. Now he's also going to take out a loan for the rest. Now, A, what will the balance outstanding on the loan be on 30 June 2039, 21 years after the loan was granted? Balance outstanding, guys. There are two ways in which you can calculate balance outstanding. I prefer the slightly longer way, 8.3.2a. The slightly longer way is using the future value formula. Sorry, I lost my train of thought there while I'm writing. Balance outstanding after, what did they say here? Was it 21 years? Yes. Now, the reason why I prefer the longer formula is because you are going to use 21 years in your answer. So what you do, guys, is you are first going to use your normal loan amount. If this is not the method that your teacher taught you, don't stress. I'll show the other method now as well. So you are going to use the loan amount and you are going to add 21 years worth of interest to it. But of course, remember that Thabo has been paying an amount every month, right? So we are going to view all of those payments that he's made every single month actually as if it is an investment that he's made. So we're almost looking at it as two separate parts. We're seeing almost like a loan that he's taking out of one amount, but then we are subtracting the value of the payments that he's made, and the difference between these two is going to be the balance that he's still owing. All right, now remember the loan amount was this 1.5 million minus 450,000. So the loan amount is 1,050,000 Rand. And we have to add 21 years worth of interest to it. So this was, let me see, what is this interest rate now? 12% compounded monthly. So 0.12 over 12 to the power of 21 years. So 21 times 12, or you can work out what that is right from the start. That is 252, or you can just write it as 21 times 12. Now we are going to subtract the future value of all of the payments that he's made, almost as if he has been investing this money all the time. So it's 11,058 Rand and 85 cents. 11,058,85. I keep forgetting this number. Let me just check again. Yes. And now I am just using the future value annuity. Just move that a bit. With the same interest rate. Again to the power of 12 times 21 minus 1. Sorry, it's a lot of writing to do. I'll move that again. There we go. Over 0,12 over 12. Right, so this is the normal compound interest formula minus the future value formula. I know that the IUB students wrote their paper 1 today. I'm so sorry. How did it go? Let me just quickly type this into the calculator and then I'll write the answer down. The NSC students are only writing on Friday. But it's still quite early, hey? I don't know why maths is always so early in the exams. Alright, I'm just almost done calculating this. It's a lot of typing in to do. Alright, I hope I haven't made a mistake. 419,000. 952 Rand and 39 cents. Okay, so that is the balance outstanding after 21 years. Guys, that is a little bit distressing because imagine you took out a loan for 1,050,000 Rand and for 21 years, every single month you have paid an amount of 11,000 Rand, but you still owe 419,000 Rand. That's terrible. Terrible, terrible, terrible. All right, now the other method is where you take, yes, I am going to do paper 2 revision as well. Just check my Instagram for the live schedule for the rest of this week. So now the other method is where you can use the present value formula, but then you have to use the present value formula for the time that's left. So this whole loan is over 25 years. So since he's been paying for 21 years, you're going to have to use the present value formula for 4 years. All right, and then you're going to have to work that out. It will give you a slightly different answer, but it will still be close enough. This paper is from 2021. All right, this is the balance outstanding. Guys, just hold on for 30 seconds. I just quickly want to go sort something out. I'll be back now. I'll be back now. Okay, sorry everyone, I'm back. Sorry. Missed payments, I've already done that, so you are going to have to check my YouTube later. Okay, I'm going to post this. Oh, that's a very broad statement. Can I please repeat what I said earlier? What does that mean? I said many things. Yes, I'm going to go live tomorrow for calculus, so I hope you guys join for that as well. Okay, now I want to talk about 8.3.2b. Guys, this question threw a lot of people for a loop when they saw this, teachers included. I was very lucky because this was in the textbook that we use. So I had actually taught my class how to do this, and I just thought everyone also did it. But turns out that that wasn't the case. All right, so and it's also saying A here, this should be B, right? Calculate the interest Thabo will have paid over the first 21 years of the loan. I am going to be live again at 4 tomorrow. Now guys, Thabo has paid a huge amount over the 21 years, right? Because they're talking about the 21 years. He has paid a huge amount, right? They are now asking us how much of what he paid was actually interest. in every payment that you make, a certain portion goes towards the interest and the other portion goes towards the capital, so the actual loan amount. Now, how do we get the difference between the two? I'm going to write a note on this for you guys. So let me just start a new page, and then I'm going to write a note, and I hope that you will copy this down. I'm just going to zoom in quite far so that I can write neatly. So here, calculating, let me move it a bit. Yes, I am going to post this live on YouTube. Calculating the interest. Sorry, my pen at this time of day is tired and then it starts doing weird things. Calculating the interest amount paid. All right, now depending on what you've already calculated, you might not have to do all of these steps, right? But the first thing that I always do is I calculate the total amount paid. So calculate total amount paid. Now, how you are going to do this is you are going to take the payment amount, whatever it is. In this question, they gave us that amount. It was 11,058 Rand, I think, and something, multiplied by the number of payments. Right, so whatever you, or Thabo in this case, was paying every month, you multiply that by the number of payments. All right, so as I am writing this down, I'm actually also going to do the calculation just underneath. So here I'm going to say total amount paid equals, it was 11,000, I think, was it, and 58 Rand and 85 cents. I quickly am going to just go back and check that. 11,058 Rand and 85 cents. Yes, that is correct. Okay, so we take that payment value that they gave us. Often you have to work this out, right? You have to solve for X and then use it. Now he was paying for 21 years every month, right? So you can do 21 times 12, or you can do 252, I think is that value. The textbook that I am working from is Classroom Maths. That's the one that we use. So the answer that I'm getting here is, this is a big answer, 2,786,830 Rand and 20 cents. Yes, I did outstanding balance just in the previous question. All right, so that is alarming, guys. The loan that he took out was actually only for 1,050,000 Rand. After 21 years, he's already paid this much, and he must still pay for another 4 years, this amount every month. Okay, so that is always your first step. If you haven't calculated that before, you need to calculate that. All right, the total amount paid. Step 2 is you are then going to calculate the capital amount paid. So how much of the loan has Thabo actually paid off over these 21 years? Right, because we know that he's paid 2.7 million, but we don't yet know how much of that was interest and how much of that was capital. Now guys, for this, you are going to use your balance outstanding. So you are going to say here, capital, you can also say loan amount if you want to, but capital amount is what they call it in the textbook. So capital amount paid, the formula for this is going to be the, let me quickly just check here, what is the wording that they used in this thing? I don't want to mess my terminology up here. So the capital amount paid, sorry, this thing went to sleep now, is always going to be your original loan amount. So let's say P value, That's probably easiest. The p-value that you use in the present value formula, right? Minus the balance outstanding. Let me just check. Is that still on the screen? Yes. Okay, so capital amount paid minus balance outstanding. Because the balance outstanding is what he actually still owes on the loan, right? So if we take the amount that he borrowed, the loan amount, and we minus how much he's still owing, that will tell us how much of the loan he's actually paid off. So remember that this loan that he took out was 1,050,000. And then the balance outstanding, let me quickly check what that was. I'm actually going to copy it across, otherwise I'm going to forget. And I'm going to just write it neatly. 419,952,39. So when you work that out, let me quickly do that. 1,050,000 minus the balance outstanding. We are getting an amount of 630,047 rand and 61 cents. Right, so that is the capital amount paid. Now, what's left for us to do, guys, he's only actually paid 630,000 rand of the loan, but he's paid 2.7 million rand in total. The difference between these two values is the interest. All right, so number 3, interest, or let me write here, calculate interest amount paid. And that formula, so I'm going to write here, interest equals total amount paid minus capital amount paid. So if you haven't already calculated these values in previous questions, unfortunately you do have to go through all of these steps to actually get to your answer. So the total amount paid was 278,680,20. And you don't have to write these formulas down every time. The formulas, those are just for you, okay? But in your actual question, or when you're answering your question, you are just going to put the values in. Equals, let me just quickly work this out. I am getting 2,156,782 rand and 59 cents. How rude that he has paid that much money for interest after 21 years on a 1 million rand loan. Terrible, but that is how it works, unfortunately. All right, guys, I'm going to zoom out so that you can take a screenshot of this page. Yes, there we go. And then I am going to have to love and leave you now. Thank you so much for joining. I hope that you learned something today. I hope that this was useful. We are doing calculus tomorrow, counting principle on Wednesday, and then we're going to do some trig on Friday and possibly something on Sunday as well if you guys want. But yeah, thank you so much for being here. Thank you for the gifts. I did see them. Jared, yes, I'm going to the previous page. There we go. November 2016. I'll see what that looks like, but it is better to do the more recent papers because then you can kind of see how they're structuring the paper currently. All right, thank you so much, guys. I will see you next time. See you tomorrow. Have a lovely evening.